Hello, everyone. My name is Brayden Dudley, and today I'll be briefly talking about my research project with Dr. Stephanie Breckner, which is titled Mineralogical and Chemical Characterization of Pyrite-sphalerite Bands from Metamorphosed Volcanogenic Massive Sulphide Deposits. So the title is quite long. So what are VMS deposits? Well, they are polymetallic mineral deposits that are important suppliers of copper, zinc, lead, gold, and silver, to name a few. Seen in this image here are what are called black smokers, which are hydrothermal vents on the ocean floor that still form even today and emit metals that, because they are heavy, they settle on the seafloor and can potentially form VMS deposits. Many of these VMS deposits have been metamorphosed, meaning that they have been altered from their original state due to elevated temperature and/or pressure conditions. And these metamorphosed VMS deposits often contain bands of pyrite and sphalerite, seen here in this image, with pyrite being iron sulfide and sphalerite being zinc sulfide. The formation of these bands is still a mystery. However, they are commonly interpreted to be formed by remobilization of metals during metamorphism. The objective of our research is to constrain the origin of these pyrite-sphalerite bands, which has implications for not only orogenesis, but also metal recovery in VMS deposits. For this study, samples from all over the world were taken, including 4 from Canada, 1 from Sweden, and 1 from Australia. And these deposits were metamorphosed at conditions between 300 and 500 degrees Celsius and pressures between 3 and 5 kilobars approximately. And the following images were taken using the scanning electron microscope. Now, the first texture we observed under the scanning electron microscope is the annealed texture, which is where pyrite grains form these closely packed aggregates with triple junction grain boundaries. The next is what is called the carious texture, which are these pyrite grains with these warped grain boundaries, which form as a result of pyrite and sphalerite being in competition for iron content. And lastly are these different generations of pyrite growth, which suggests recrystallization of pyrite during metamorphism. Further work on this subject will include examining the samples using EBSD to further investigate if the textures found in these figures formed during deformation or not, as well as examining the samples using both EPMA and LAICPMS to look for elemental variations within grains of pyrite and sphalerite. Now, there are no definite conclusions so far. However, the current results support a metamorphic origin for these bands, resulting from recrystallization of pyrite within sphalerite. Thank you all for your time.